Hi everyone, we're going to use the ratio test to determine whether each series is convergent or divergent. This is part 2, and before we get started, let's notice that we have this 2 lead. This is like 2 over 1 squared. So the first thing we want to do is find the nth term. This is your first term plus your second term, your third term, and a sub 4. And so your nth term, if you look at this, the numerator is going to be 2 to the nth power, and the denominator is going to be n squared. And you can see the pattern here if you look at that. We also, so that's your nth term. You also want to look at your next term. And your next term is going to be 2 raised to the n plus 1 power over n plus 1 squared. That's your next term there. Okay, so we're going to use the ratio test, which is r equals the limit as n approaches infinity over our next term over our previous term. And remember, this can be written as 2 times 2 to the n. So that's going to be 2 times 2 to the nth, and I'm going to go ahead and FOIL this out. N squared plus 2n plus 1 all over 2 to the nth over n squared. Now I'm going to simplify this complex rational by when you flip this and multiply, this is going to go in the numerator, and these two get multiplied. So these two get multiplied. So we're going to get, at this point, we're going to get 2 to the nth times 2 to the n squared over, and you can multiply these two, so you get 2 to the nth times n squared plus 2n plus 1. And what you notice, these 2 to the nth powers cancel. Now that we have this, we're going to use our technique of dividing everything by my highest term here, which is n squared. So we're going to have the limit as n approaches infinity over 2 n squared over n squared divided by n squared over n squared plus 2n over n squared plus 1 over n squared. Now this leaves 2 in the numerator, and the denominator you're going to get 1 plus 2 over n plus 1 over n squared. And from our knowledge of limits, we know that when you take these two, the limit as n approaches infinity are 0. So this is going to be 2 over 1 plus 0 plus 0, which equals 2. So since my r equals 2, an absolute value of 2 is not less than 1, this series is divergent. Okay, the second one I have is this one, and we're going to do the same thing. We're going to find our pattern, our nth term. So we're going to add that. Our nth term is going to be 2, because the 2 is not changing, and the denominator is just going to be, let's see, n plus 1 times n plus 2. So my next term is just going to be 2 at the top again, because that's always going to be 2. And the denominator is just going to be n plus 2 times n plus 3. Okay, so then we do our ratio test. And that's going to be the next term And I'm going to go ahead and FOIL this out. So it's going to be n squared plus 5n plus 6 over 2 over n squared plus 3n plus 2. And I should have done the limit here. So basically the 2's will cancel, and this is going to be 1, 1. So this gets flipped around. So our r is the limit n approaches infinity of n squared plus 3n plus 2 over n squared plus 5n plus 6. Now I'm going to pick the term with the highest power, n squared, and I'm going to divide everything by n squared. So that helps me take the limit better. So you have n squared over n squared plus 3n over n squared plus 2 over n squared, all divided by n squared over n squared plus 5n over 5n over n squared plus 6 over n squared. And that simplifies to the limit n approaches infinity, 1 plus 3 over n plus 2 over n squared, and the bottom 1 plus 5 over n plus 6 over n squared. Again, when you take the limit of these four, these all go to 0. And what you're left with is 1 divided by 1. So the limit as n approaches infinity is 1. That's a constant. Since it equals 1, the test provides no information. So when it equals 1, the test provides no information. Whoops, sorry. So that's no information. Okay, the next set is a little harder, and it's going to be 3 problems. Thank you. Have a nice day. Bye-bye.